Hello everyone. In this session, we will walk through how computer use agent can interact with a real desktop application using a layered execution approach and focus on how the agent observes the screen, decides the right action executed, and then verify whether the task was completed successfully. So the foundation setup is the Core driver. Think Core driver as a mechanical execution layer for a computer use agent. It does not decide what to do on its own. Instead, it exposes the operating system's native accessibility and input API as a structured tool. This allows an agent to launch the application, read the current window state, click the button, perform different action, press keys, verify the results on a real desktop environment. The important point is that Core driver performs the action and returns the observations, while the intelligence planning, interpretation, recovery, and verification is built above it. The overall agent architecture follows a five-layered cascade, right? And if we look at all these five layer, the first layer extracts the user intent and build the structure plan. The second layer uses the deterministic action, whether the task is predictable or not. For example, the calculator expression or opening a new VS Code, the repeatable steps which are involved, right? If execution deterministic execution is not enough, the agent moves to the accessibility tree layer, which it reads the semantic UI elements from the application. If that still does not provide enough information, the agent falls back to the vision layer, and the vision fallback basically uses the screenshots to understand what is visible on the screen. And finally, the verify recovery layer checks whether the expected result was actually achieved and handle the fallback summary to the final if any final output is missing. So basically in this one we have a key principle of a scan, act, and verify loop, where the agent scans the active window using get window state. Then it performs an action such as click, press any key. After that, it scans again to confirm whether the action changes the state as expected. This loop is critical because UI elements can change after every action. So element indexes could be treated as a temporary turn scope references. So in this example, we have used three queries, where first one we have used calculator to evaluate the expression 25 into 4 divided by 5, and we got the result as 20. In the and If I show the screenshot of this one, how what we had done basically. So if you see, yeah, so if you see the trajectory. So when we executed this result, it actually opened the calculator app, then evaluated the expression, and it has captured the final result. So basically, these screenshots are being captured by the code solution itself. Thereafter, we had another query where we have mapped the distance between uh, two cities, which is uh, uh, which is Delhi to Mumbai. And here, if I show the trajectory, it actually open everything, and then eventually, if I quickly show it here, yeah. So it has opened the Chrome browser, typed in the detail, and then loaded the map and calculated the, and then since it had to pass on to the vision, it has calculated the distance of roughly 1400 kilometers, and that is something was captured in the uh, that was something captured in the log file itself. So if you look at the log files, it captured a distance of around 1400 kilometers. So after that, we had one more query where we have opened the VS Code and tried to write a code in a Python to read a CSV file. There were some issues while reading the working behavior, and that has been documented. For example, the final result was coming empty, and those changes were fixed. In order to move toward the opening the VS Code, we had to go to the file, new file, and that instructions, the key instructions, what keys needs to be pressed, the combination, for example, Control N, Alt F, and so on. um, so those things were done, and we can show it actually here. So if I want to use the computer skill to open a new instance of VS Code and create a new Python file and to read a CSV file and make sure that the code is aligned to what is being, you know, indentations are aligned, because we also observed that some of the cases due to colon and all, the indentation had some issues. So those things were handled by the LLM call itself. And in this one, the expected behavior is that the it should go to the file implicitly, open a new file, and yeah, and write the Python code. See here, so automatically it has gone over, and within fraction of seconds it has just written the complete code, and we can replace our respective code file and CSV file and read the data. So, and the final expression also, it is giving that deterministically it has done that. And the log actually tells me that what skills he has used, right? How the planner, how the computer skill agent, computer agent skill, and the formatter has been worked. So to summarize, this architecture shows how a computer a user agent can combine the deterministic execution, accessibility based perception, vision, fallback, and verification. The biggest lesson is that automation should not stop at performing an action, it must also verify the result. That verification step is what turns a fragile demo into a reliable agent workflow. Thanks all.